right, so we had to answer questions 13, 14, and 15 on page NOS 29. So we're going to talk about that quickly before we go into the new chapter where we start talking about the beginnings of physics. So this is to wrap up that Nature of Science unit. We're not going to take a test on it. We're not going to have any quizzes on it. The fact that you did the lab is good enough for me. Because really all this is to get you to start thinking scientifically, right? That's why we wrote the hypothesis the way that we wrote it, because there's certain ways that you need to talk, certain ways that you need to write when you're dealing specifics of science. So, question number 13 asks you, was your hypothesis supported? How do you know? So the goal was to hold a textbook. Now, I would have preferred that they all hold at least 2, but many of you did not achieve that goal. So, did your design hold a textbook? So, for 13, you had to answer, how many textbooks did your bridge hold? And then, did that support your hypothesis? Meaning, was that the strongest configuration that you could have? So, the record holder was
7.
how many?
7.
7. Not by you. So, 7 textbooks was the most that we got. Okay? There's a couple in 7th grade that got 6 and crashed on the 7th. So, 7 is the record holder. So, Leah, what was your configuration for 7 textbooks?
What do you mean? What was the things?
Where did you put your tetrahedrons?
Oh, like the outside, the corner.
So if our piece of paper is right here, this is where you put your triangles?
Yeah.
Okay? So why? Why did you put them here? What was your thought process?
So it would have equal weight on both sides.
So that you'd have equal weight? Okay. What else does this configuration do?
Spreads out the weight.
Spreads the load, right? It spreads out the load much like snowshoes, right? So instead of all of the mass of the books being distributed here down the middle, now you have it spread out throughout the entire structure. Does that make sense?
Mm-hmm.
Okay, some of you I saw, you tried to put your tetrahedrons all together here in the middle, which is fine. That supports the weight in the middle, but it also supports all of the weight in the middle. All right? Now, I also heard some of you when you came up here, you were like, this one is my weakest one, so I'm going to put this in a specific spot. Now, if the load is equally distributed, is that going to make a difference?
No.
No. What did you find out?
I did the same.
It did the same thing. The tetrahedron that you thought was the weakest ended up being where it broke, right? And of those ones that you thought were the weakest, what was the reason that you thought it was the weakest?
It was loose.
The knots were the loosest. So that translates then into the gusset plates not doing their job, right? Mm-hmm. So then that takes us into question 14. Compare and contrast your bridge with the real bridge. So the real bridge failed because the gusset plates were too thin and weren't able to withstand the weight that was on top of the bridge, correct?
Mm-hmm.
So when your bridge broke, why did it break?
Too much weight.
For the gusset plates, or your knots, so your tetrahedrons collapsed and fell apart. Did any of your knots, and I didn't pay that close attention when you pulled them off, but did any of your knots actually give way and actually break? So you ended up having pieces of the straw actually coming off of your tetrahedron? Raise your hand if that happened. It happened a bunch in some of the other classes too. Like as it collapsed, I literally saw pieces of straw like flying off of the cart and all over the floor. So that's going to happen. So what you found out, compare and contrast, is your bridge failed similarly to the real bridge. Make sense? Mm-hmm. That's what you would expect. What steps of the scientific inquiry did you use in this activity? What would you do next to figure out how to make a stronger bridge? So, what it's asking you is, within the steps of the scientific method, which ones did we use during this experiment?
Hypothesis.
What did you have to do first?
What did we have to do?
Before you could form a hypothesis, you had to what?
Build the stuff.
Nope.
Ask the question.
You had to ask questions first. Right? Our question ultimately was, how do we build a bridge that can hold up textbooks? Right? That was our question ultimately. So then we got into talking about ways to answer that question. So that's the inquiry part. You made an observation. The bridge failed. Why did it fail? How did it fail? I need to make a model that will be the strongest. How am I going to do that? So then we started talking about geometry, shapes that are strong, ways to disperse weight over larger amounts of space. And then we went into building. Then you formed your hypothesis. Then we tested the hypothesis, so on and so forth. Does that make sense?
Mm-hmm.
Questions? Did anybody have questions about this? All right, good. So let's go ahead and open, everybody take your book out, and we're going to open up to page number 6. Page number 6. Should we have like the Blue Angels or something on it? Right?
Yeah.
So, what we're going to talk about now, right, we're getting into the beginning of physics. The beginnings of physics. And physics is all about motion. And how does motion affect objects? How does motion affect your force that you can put? All of this stuff. Motion is physics 101. But how do we describe motion scientifically? Right? So when you talk about motion just, in a normal, regular conversation, you talk about things moving from point A to point B, right? Like you leave your house, drive to school, get dropped off. All of that is how you're moving, right? You get out of bed, eat breakfast, you get in the car takes you to school, you walk down the stairs to your locker and go to your classroom. That's all motion, right? But there are specific ways to describe motion when it comes to science and objects, and that's what physics is. So when you start to describe motion, the first thing you need to have is your reference point. You don't have to write this down because you'll be doing the vocab here in a second. Is a reference point. All right? Then you start talking about position of the object and motion, displacement, right? I saw outside of Mr. Hale's room you guys drew maps, right? Mm-hmm. Right? All of that map drawing is based on what?
Motion.
What?
Physics. No.
I didn't, what did you say?
Our school and our house.
So, how many, like you guys, what did you draw? Like, I saw the maps, but I didn't really look super close. What are the maps? Oh, it's Logan.
It was our route to school, like from our house. And
It was your route to school. Okay, that makes sense. So it's your route to school. So in order to draw that map, what was your reference point?
Google Maps.
Nope, that's what you use.
Our house.
Your house. That's your house and
School.
school. Those are your two reference points, right? Your reference point is where you're at and where you want to get to. Those are your reference points. Where you start, where you finish. Those are reference points. All right? And then as you started to draw your map, you were talking about how you were moving and you were describing your position. Right? If you think about how maps work, even like Google Maps when you're getting directions in your car to drive somewhere, right? It's telling you, go this way for 3 miles, then take a left, go on that road for another 2 miles, then take a right. Right? It's giving you position and direction every time. All right? And that's what you did when you built those maps. And it also talks about displacement, meaning what you are moving if you're talking about 2 dimensions or 3 dimensions. Okay? So when you talk about describing position, okay, you need a reference point to describe that position. Right, like the you are here. How many people have gone to the mall? Maybe not recently, but been to the mall, right?
Which one? The sketchy mall?
I don't give a crap which mall it is. You ever go look at the mall directory because you can't remember where a store is right off the top of your head? Right? What do you see on that map?
A map.
Yeah, you see an arrow usually with a dot or something that says you are here. Right? That is your position. It's not a reference point. That's your position. This is where you are. Okay? It tells you where you are. Then from there, you have to figure out what motion do I have to take in order to get to where I want to go. Right? Do I got to go upstairs, downstairs, past the food court, whatever. All right? So, what I want you to do is for lesson 1, you've got 4 vocabulary words. Lesson 2 talks about speed and velocity. There's 5 vocabulary words. Those are different things, by the way. Speed, velocity, and acceleration. Those are all different things. And then lesson 3, you have 1 vocabulary word. And I think that's it. There's only 3 lessons. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vocabulary words. Here's what I would like you to do. Some of you are jumping the gun because you don't remember how they do things.
No.
So, here's your notebook paper. I need 10, right? This is 12 squares. You're only going to need 10 of them. Okay? 10 squares. In there, what I want you to do is you're going to write the word, whatever the word is, I don't care, whatever the word is, vocabulary word, a definition, preferably of 5 words or less. Okay, and then a picture. Now, for physics is a lot of math. All right, for some of you, that's not going to be a problem. For others that hate math, this unit is going to be a little bit more difficult for you. All right, but physics is a lot of math, so I am okay if your picture for a given word is the math equation for figuring out what that is. Okay? Or the graph of that word. So you will see examples in the book when you get into lesson 2 where it's talking about speed, constant speed, instantaneous speed, average speed, velocity, right? There's equations for that. There's graphs that they show you for that. if you use those as your picture, I am fine with that. Alright, so if you can do it without reinventing the wheel and making something a lot more difficult than it needs to be, then do it. The word, a 5-word definition, and then a picture. If that picture is a math equation or a graph, 100% okay. Alright? Questions? I'm going to give you some time to do that now. We're just about halfway through. The bell's going to ring here in a second for the 30 mark. So we're about halfway through. I really hope that 30 minutes is enough time for you to do 10 words. Because I would prefer you not to have to log on to the book tonight and do this for homework. But if you don't finish the 10 words, please finish it tonight.